This video covers Chapter 2, Section 1 of Math 1316, Trigonometry, dealing with right triangle trigonometry. I'm David Dipple, Lone Star College, Montgomery. Okay, looking at some definitions. Sine theta, cosine theta, and tangent theta. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. If you have your angle, the opposite is farthest away, adjacent is next to it, and the hypotenuse is the longest side of the right triangle. Now the reciprocal functions, if you flip those over, secant is if you flip over cosine. If it starts with an S, flip it over, you get cosine, which is hypotenuse adjacent. Cosecant is the reciprocal of sine. Again, if it starts with a C here, the reciprocal is S, so it's going to be hypotenuse opposite. And cotangent is tangent, adjacent, and opposite. Now, if we look at this triangle, if we have an opposite of 4, an adjacent of 3, if you use Pythagorean theorem, 3 squared plus 4 squared, square rooted, is 25, square root is 5. Look again at our trig functions. Again, sine opposite is 4, hypotenuse is 5. Cosine is adjacent, 3, hypotenuse 5. Tangent is opposite, 4, adjacent 3. Secant is just cosine flipped over, so it's 5 divided by 3. Cosecant is sine flipped over, so it's 5 divided by 4. Cotangent is tangent flipped over, so it's 3 divided by 4. Now we have relationships between the two cofunctions. Sine and cosine are called cofunctions, and if you have an angle like 10 degrees, its complement will equal the cofunction. So if you have sine 10 on your calculator, that's the same as pressing cosine of 80, because 10 and 80 are complementary, and the sine and cosine are cofunctions. Secant and cosecant are cofunctions, so 40 will relate to 50. And again, if you take your calculator, push secant of 40, that's the same as cosecant of 50. Okay, cotangent of 22 is going to be the same as tangent, its cofunction, and 22 from 90 is 68. Cosine and sine again are cofunctions. If one of them is 90 minus x, sine is going to be x, because if you take x and add it to 90 minus x, you will get 90. Now, suppose we look at all 6 trig functions for this triangle. If we have 30 for our angle, opposite is x, hypotenuse is 2x, because on a 30, 60, 90, you double the short side to get hypotenuse. You put the square root of 3 to get the adjacent angle. If we look at sine of 30, it's opposite over hypotenuse. X over 2x reduces to 1/2. Cosine is adjacent over hypotenuse. X squared of 3 divided by 2x. And again, the x's cancel. This time we get square root of 3 over 2. Tangent, opposite over adjacent, is x over x squared of 3, which reduces to 1 over the square root of 3. Now if you do the reciprocal functions, just flip them over. Secant, flip over cosine, get 2 over the square root of 3. Cosecant, flip over sine, 2 over 1, which is 2. Cotangent, flip over tangent, square root of 3 over 1 is the square root of 3. Okay, we're looking at 45, 45. If these two sides are 1, the hypotenuse gets the square root of 2, so we have the square root of 2. And if we go through all our trig functions again, sine opposite over hypotenuse, which is 1 over the square root of 2, or if you rationalize it, you get square root of 2 over 2. Cosine, same thing, adjacent hypotenuse, and tangent, opposite adjacent, which makes 1. In the reciprocal functions, secant, flip over cosine, get the square root of 2. Cosecant, flip over sine, you get the square root of 2. Cotangent, flip over tangent, and you still get 1. Now, if you fill out this table, using your calculator or using the triangles that we've done, sine of 0 is 0. Cosine of 0 is 1. And tangent, if you make a fraction sine over cosine, you get 0. 30, the sine of 30, if you look back at the triangle we did earlier, is 1/2. Cosine of 30, square root of 3 over 2. And tangent is sine over cosine, so it's the top numbers 1 divided by the square root of 3, and that's the tangent. 45, sine and cosine were both square root of 2 over 2 if you rationalize them. And tangent, if you make a fraction out of those, square root of 2 divided by the square root of 2 makes 1. 60, sine, if you look at 60 degrees from the triangle we did earlier, you get square root of 3 over 2. Cosine is 1/2. And tangent, if you take square root of 3 divided by 1, because tangent is sine over cosine, you get square root of 3. 90, the sine of 90 is 1, the cosine of 90 is 0, and then sine divided by cosine, 1 divided by 0 is not defined, so that's undefined. Now if you take those same values and put them on a circle, this point right here is 1, 0, which is our sine, cosine and our sine. 30 degrees, if you have a 1 for your hypotenuse, going backwards you get a 1/2, and putting the square root of 3 on it, you get square root of 3 over 2. And if you take those numbers, the cosine is adjacent over hypotenuse, square root of 3 over 2. The sine is opposite over hypotenuse, which is a 1/2. And the tangent, if you make a fraction out of those, 1/2, or 1 rather, divided by the square root of 3. Okay, 60, the same thing. If your hypotenuse, if the side going out to the circle is 1, cutting it in half for the short side is 1/2. Putting the square root of 3 is square root of 3 over 2. And again, cosine and sine. The cosine will be adjacent for hypotenuse, which is 1/2. The sine is the second number, opposite over hypotenuse, which is square root of 3 over 2 over 1. And tangent, the sine number, square root of 3 divided by the cosine is 1, so it's just the square root of 3. Now if we look at the 45-45 triangle, if the hypotenuse is 1 again, we will divide by the square root of 2, which makes square root of 2 over 2, and square root of 2 over 2. Those two sides are always the same. Now, if you put that into a point, the sine opposite over hypotenuse, and the cosine adjacent over hypotenuse, you will get cosine square root of 2 over 2, sine is square root of 2 over 2, and the tangent, if you make a fraction, sine divided by cosine, you get 1. So that's all the numbers that we've put on the circle. Now, taking that information, we can actually utilize it, and it's very important that you write it down on a circle, get it memorized, or know easily how to find it. Suppose you want the sine of 30 plus the cosine of 45. Now the sine of 30, if you look at the circle, or if you look at the triangle, the sine of 30 is 1/2. The cosine of 45 is square root of 2 over 2. Since they have a common denominator, that's 1 plus the square root of 2 divided by 2. Sine squared 60 plus cosine squared of 60. If you put in the numbers, you'll get 1. Sine squared plus cosine squared is always equal to 1, but we can go through the steps. Sine of 60 is square root of 3 over 2 squared. Cosine of 60 is 1/2 squared. This turns out to be 3/4. That turns out to be 1/4. 3/4 plus 1/4 makes 1. But again, sine squared plus cosine squared is always equal to 1. That's a Pythagorean identity. Hey, tan squared plus secant squared. Well, that's not an identity, so we'd have to rearrange it to make one. Tan of 30 and secant of 45, those are two different angles also. So tangent of 30 is 1 over square root of 3. Square that. Secant of 45 is 2 over the square root of 2 because that's from cosine. Square that. This gives you 1/3. 4 divided by 2 is 2, so it's 2 1/3. Or if you make it into an improper fraction, 2 times 3 is 6 plus 1 is 7/3. So on my WebAssign, which is where your assignments are, if you'll go through, they're going to see problems like this, finding sine and cosine and tangent of different angles. So you need to get the circle memorized or be able to write it down very quickly and then utilize it this way.